Dear students, greetings for the day. In the previous class, we discussed the multiplication of vectors. Multiplication vectors is two types. First one is scalar product or dot product of two vectors, and another type is vector product or cross product of two vectors. In the previous class, we discussed the scalar product and its properties. So that A bar and B bar are two vectors, then their scalar product is represented by dot between the A bar and B bar. So A bar dot B bar is equal to modulus of A bar into modulus B bar into cos theta, where theta is the angle between A bar and B bar. Here, as the name indicates, the product of A bar and B bar gives the scalar quantity. So it is called scalar product. So scalar product of two vectors is defined as the product of their magnitudes and cosine angle between them, or it may be defined in another way also. The scalar product of two vectors is defined as the product of the magnitudes of the first vector and magnitude of the second vector in the direction of first one. Therefore, A bar dot B bar equal to magnitude of A bar into B bar direction in the A bar, that is A bar into B bar cos theta. Therefore, A bar dot B bar equal to modulus of A bar into modulus of B bar into cos theta. And this scalar product obeys commutative law and obeys the laws of multiplication also. It is also distributive. Similarly, now we discuss about the vector product of two vectors. Now we define this vector product as a vector whose modulus is the product of the magnitudes of the two vectors and sine angle between them into n bar, where n bar is a unit vector in the direction of A bar cross B bar. So if A bar and B bar are two vectors, first we define vector product of two vectors is a vector whose magnitude is equal to the Consider two vectors a bar and b bar. Let the angle between them be theta, and n bar is a unit vector in the plane which is perpendicular to both a bar and b bar. Now vector product gives another vector c bar whose direction is perpendicular to both a bar and b bar. So vector product of two vectors is defined as a vector whose magnitude is equal to the product of the magnitude of the first vector and magnitude of the second vector and sine angle between them. Let us know in detail about this. Let this be a bar and let this be b bar. Let there be two vectors a bar and b bar whose angle between them is theta, and when we, that is perpendicular to this plane vertically up, so in xy plane if we consider this, in y plane, in xz plane if they are this, then in y plane another vector c vector whose magnitude is, so a bar cross b bar is in the direction of y axis. So this part is magnitude scalar quantity. Where n bar is a unit vector in the direction of a c bar or a bar cross b bar. So if two vectors a bar and b bar which are inclined at an angle theta with each other, then the resultant is another vector. So here multiplication of two vectors a bar and b bar gives another vector c bar whose magnitude is modulus of a bar into modulus b bar into sine theta, and whose direction is given in the direction perpendicular to the, in the plane which is perpendicular to both a bar and b bar, and so when this magnitude is multiplied by unit vector n bar in the direction of c bar or a bar cross b bar, then we obtain that vector. So here modulus of a bar b bar is equal to ab sine theta. That is the magnitude of vector product of two vectors is defined as the magnitude of the first vector into magnitude of the second vector into sine angle between them. Now when we take this anti-clockwise direction, if we take this in anti-clockwise direction, then this is this resultant is not in the upward direction, it is vertically downward direction. So in this case this is because negative vector of c bar in opposite direction, then it is equal to minus of a bar cross b bar, that equal to minus ab sine theta into n bar. So here a bar cross b bar is not equal to b bar cross A bar. But when we consider in the direction B bar cross A bar, then it is in the opposite direction. So negative vector of C bar. Therefore, A bar cross B bar is equal to, from the figure, minus of B bar cross A bar. If we take reverse direction, then this is the equal to the negative vector of A bar cross B bar. So from this expression we observe that vector product does not obey commutative law, and from this expression we observe that A bar cross B bar is equal to minus of B bar cross A bar. Now, as the vector here C bar is the resultant of the two vectors A bar cross B bar. Now, as it is a vector, it has magnitude and direction. Magnitude is given by A bar magnitude into B bar magnitude into sin theta, whereas its direction is here, acting in the plane perpendicular to both A bar and B bar plane. So generally direction is found by using the right hand screw rule. Direction of N bar is found by using right hand screw rule. Direction of A bar cross B bar. First one, it is found right hand screw rule. Second one, right hand thumb rule. So by using these two rules, we determine the direction of the resultant vector C bar. Here, when we consider two vectors A bar and B bar, then if we take nail at the common tail of the if we rotate in the direction from A to B, then when we rotate the screw in the direction A to B, then it moves up. So it moves in the right hand side. So it is known as the right hand rule, screw rule. So when a screw is placed at the common tail of the two vectors A bar and B bar and rotated by right hand from A to B, then the direction of advancement of the screw gives the direction of the cross product, that is C bar equal to A bar cross B bar direction. Second one, right hand thumb rule. If we place here right hand like this and A bar, then A bar and B bar are in the circular directions making an angle theta with A bar, then this right hand thumb shows the upward direction, that is in which the resultant So when the right hand is placed at the common tail of the two vectors a bar and b bar in their plane, then the curved figures show the rotation from a to b bar. Then the extended thumb indicates the direction of the cross product c bar direction. Now let us discuss the examples for vector product. First one, moment of force or torque. Here, moment of force or torque is represented by tau bar because it is a vector. So, torque is the vector product of force and radius vector. R bar cross F bar. So, when a body rotates in this circular direction, in anti-clockwise direction, then the body is pulled in the direction of F bar when it is obtained by drawing tangent, and the body while rotating like this, the moment of force torque is here obtained by taking the scalar product of radius vector r bar and force F bar. So here radius vector is one vector, force is another vector. So here Rf cos theta. Sin theta. So this is one example, and another is linear velocity. So linear velocity here of the body when rotating along the circumference of the circle is obtained by cross product of radius vector into angular velocity. So V bar is equal to R bar cross omega bar. So resultant vector is in this direction. For example, if it is R bar in this direction, at this point. Next, third example, angular momentum. Angular momentum of the body. It is obtained by taking the product of radius vector into momentum of the body. Therefore, R bar cross P bar. So, angular momentum vector is obtained by taking the cross product of the two vectors, radius vector and momentum P bar. Now, let us know the properties. Now, we discuss the properties of vector product. First one, vector product is a vector product quantity. Or vector, it has both magnitude and direction. Vector product obeys distributive law. Our vector product is distributive simply. Next, product obeys distributive law. If there are three vectors A bar, B bar and C bar, then A bar cross B bar plus C bar is equal to A bar cross B bar plus A bar cross C bar. This is simply obeying the algebraic multiplication. Third one, vector product or cross product does not obey commutative law. Vector product is not commutative. If A bar and B bar are two vectors, A bar cross B bar is not equal to B bar cross A bar. Already we discussed this one. But A bar cross B bar is equal to minus of B bar cross A bar. Third one, magnitude of the vector product. So the product of two vectors here is a vector quantity whose magnitude is given by another vector whose magnitude is bar, where n bar is unit vector in the direction of A bar cross B bar. So C bar magnitude is AB sin theta, or from this we may write modulus of A bar cross simply B bar is equal to modulus of A bar into modulus of B bar into sin theta. From this we write sin theta value. If we know the cross product value, then sin theta is equal to cross product of two vectors and it taking its magnitude and dividing the magnitude of cross product of two vectors with the product of their magnitudes, then we obtain the sin angle between them. From this, theta is equal to sin inverse A bar cross B bar by modulus of A bar into modulus of B bar. Now if two vectors are perpendicular to each other, so we consider the values of theta. If two vectors are parallel to each other, then theta equal to 0. Since sin 0 is 0, then into that equal to AB n bar. Maximum value for vector product is obtained when theta equal to 0 degrees. When two vectors are perpendicular to each other, then if theta is equal to 90 degrees, then we find what is the value of A bar cross B bar. Sin 0 is here as it is equal to 0. Here if theta is 0 degrees, then the two vectors are parallel and their vector product is 0. When the two vectors are lying in the same direction, then their vector product is 0. And if they are perpendicular to each other, then theta is equal to, here since sin theta is equal to maximum value is sin theta is 1 sin 90 1, therefore magnitude of A bar into magnitude of B bar into, since this is equal to 1 into 1 n bar, simply we may write AB into n bar, which is the maximum value for vector product. When we take the cross product of the equal vectors, that is with the same vector, A bar cross A bar is from this expression magnitude of A bar into magnitude in case of B also A bar and sin 0 decrease into I bar, since next direction or n bar, then 0 into something is 0. Now we discuss about the unity vector in the directions of x, yz directions, that is I bar, j bar and k bar. From this we consider I bar cross I bar. That is I bar into sin 90 into since it is equal to 0 there, and j bar cross j bar is also equal to modulus of j bar into from this it is equal to 0, and k bar cross k bar is equal to because 1 into 0 into n bar. Now we consider the scalar product or vector product with the y direction and z direction vectors with I bar. I bar cross j bar, vector product with the I bar is the unit vector in the direction of x axis, j bar is the unit vector in the direction of y axis. Then we here find the value of I bar cross j bar. Modulus of I bar into modulus of j bar into sin 90 degrees into unit vector perpendicular to I bar and j bar. Here I bar is in x direction, here j bar is unit vector is now perpendicular to both is xy plane is z direction, in this direction, perpendicular to the board towards the camera, but in figure it is shown as this one. Here unit lengths, so modulus of I bar is equal to 1, modulus of j bar equal to 1 in this direction, modulus of z bar equal to 1 k bar z direction. So here perpendicular to x axis y axis plane is z axis. So in that direction, z direction, unit vector is k bar. So I bar cross j bar direction is k bar direction. So unit vector in perpendicular plane is k bar, that is in z direction. Therefore, since my magnitude of unit vector I bar is 1, magnitude of j bar is also equal to 1, and sin 90 is maximum value 1 into k bar. Therefore, I bar cross j bar is equal to k bar. Now we consider therefore from this I bar cross j bar is equal to k bar. Similarly, j bar cross k bar is equal to I bar, and k bar cross I bar is equal to j bar. And if we consider the reverse directions, then j bar cross I bar is equal to minus k bar into opposite direction, and k bar cross j bar is equal to minus I bar and I bar cross k bar is equal to minus of j bar. We obtain their products by writing complete equations. We obtain this one. Now we consider the vectors which are resolved in three directions. We consider the components in xyz directions of the vector a bar. Then if a bar equal to axi bar plus ayj bar plus magnitude of a bar in z direction is modulus of a bar z or a z into a bar, and b bar is equal to bxi bar plus byj bar plus bzk bar. Now we find the vector product of a bar and b bar. That is a bar cross b bar value. And a bar cross b bar is equal to by multiplying the first term with these three terms, I bar cross I bar is 0, and I bar cross j bar is k bar, I bar cross k bar is minus of j bar. So remembering those values, a product can be equal to a by bz minus a by bz into I bar minus of minus bxj bar plus k bar into axby minus bz. So this may be written as determinant of the matrix, 3 cross 3 matrix. this is the A bar cross B bar is a vector is HAK like this. So this is nothing but the determinant value of this 3 cross 3 matrix by writing like this. Now we obtain unit vector in the direction of A bar cross B bar is obtained by unit vector in the direction of A bar cross B bar is obtained by here A bar cross B bar magnitude by its magnitude value. So here A bar cross B bar value is determinant value of this matrix, and now we know the physical interpretation of vector product. If A bar and B bar are two vectors, and if they are represented by the two adjacent sides of a parallelogram, and if theta is the angle between the two vectors, then the area of the parallelogram is given by the here area of the parallelogram is given by the OPR. It is nothing but the magnitude of the vector product of the two vectors A bar and B bar, and area of the triangle from the figure is equal to half of the area of the parallelogram. This is the physical interpretation of vector product. So thank you for listening the class, and we have take up some examples in the next class.